Since we didn't get to this during class, I'm just going to record the notes or what I would have taught you guys. If you could watch this before the next class, that would be super helpful. So these are in your notes packet. If you could copy them down, then we can just talk about them briefly if you have questions. But I think most of them are pretty self-explanatory. So this is the first, this is the first section, or the first part of your notes, and the second part there. So first off, order of integration matters. So what I mean by that is if your bounds, we usually go lower bound to upper bound, you can switch your bounds just by negating the integral. So basically this says we're going from B to A. If I want to travel backwards, we're going to see when you travel forwards, it's like positive area. If you go backwards, it negates the area that's there. So you can switch your bounds just by negating the outside. The second one should be kind of obvious. Remember, this is area. So what's the area under the curve from A to A? You're not moving anywhere, so there would be no area underneath that curve there. 3, the constant multiple rule. If you have a constant on the inside, you can bring it to the outside like I did here. So you can see this k was on the inside with the k times f of x. That k can go to the outside. Where that might be helpful is if you have a integral that's maybe not so nice to work with, we can bring the constant out to the outside and then just deal with what's on the inside there. Same thing with negatives. So the negative that was on the inside here can be brought to the outside. It's just a constant of -1. Your sum and difference rule, this one says that I can split the integrals up. If I'm adding two things together, I can split them up into their own separate integrals. Again, this might be helpful if you have one really easy integral to take and one more challenging integral to take. So you could get the easy one out of the way and then deal with the more challenging one. Notice the bounds stay the same, so from A to B and then from A to B. Your additivity rule, this one is similar to something that you saw in geometry. I think it was called transitivity or something like that. But basically it says if I have the same function, so f of x and f of x, and I'm going from a to b of the first integral plus b to c of the second integral, I can combine those into one integral that goes from a to c. We often see this as more of a subtraction type question. So saying like if you know that the entire area is something, and you know a little piece of the area is something else, that allows you to find the missing piece of the area. We'll see an example of that in a few minutes. And then the last two down here, max min inequality. This just gives you bounds as to where your area or your integral has to be between. So you'd find the minimum value of f, and you multiply that by your bounds b minus a. That has to be less than or equal to the area under the curve, not the total area, but the integral, which has to be less than or equal to the maximum times the maximum value of f times b minus a. And domination, this is another one that just gives you more of like an idea of what an integral could be. If your f of x graph is greater than your g of x graph, or like I like to say, it's just on top of. So let's say you've got up here, and we'll call this one f of x, and we'll call this graph down here g of x. Then what this says is the area underneath f of x is greater than the area underneath g of x. Okay, so if one is greater than the other, then their area is greater than the other one. And that happens to if f of x is greater than 0, meaning that it's always above the x-axis, then that means that your area or your integral will also be always greater than or equal to 0. Okay? So hopefully you got those filled in. If not, pause and rewind a little and go back and fill those in. You can see me next time with questions. A few quick examples. This one right here, you may want to try these quick. So if you want to pause and then see if you can figure out what they are. And then I'll go through these now too, so that you can see them. But again, I would recommend that you try them first and then go back and check your answers. So pause now. And then if you're back, then we have this first one here is from 4 to 1 of f of x. So if I look up here, I know from 1 to 4 of f of x equals -2. So by the order of integration rule, that very first one right there, it says that if I negate my integral, I can switch the bounds. So I can go the negative integral from 1 to 4 of f of x dx. So that means that this is equal to the negative, and up here it says 1 to 4 of f of x dx is negative 2. So a negative negative 2 is equal to a positive 2, which should be the answer. The second one here, we've got negative 1 to 4 of f of x. So let's look up here. I've got negative 1 to 1 of f of x dx equals 5, and 1 to 4 of f of x dx equals negative 2. So this is that additivity rule, which says I can actually split this apart into two separate integrals. So I'm going to have the integral, actually I'll write that down here where I have a little bit more room. I'm going to have the integral from negative 1 to 1 of f of x dx plus the integral, as long as this bound right here is the same as this one, this additivity works, so 1 to 1 of 4 of f of x dx. So those, this integral right here can be split into these two separate ones. So from negative 1 to 1 we see above, that's 5, plus the integral from 1 to 4 of f of x is negative 2, which gives me a positive 3. Okay, and then this one right here has a lot of different rules in it. So we're working with f of x and h of x this time. So because of that, I might split this up into two separate integrals. So I'm going to do the negative 1 to 1 of 2 times f of x dx plus the integral from negative 1 to 1 of 3 times h of x dx. So by additivity, not additivity, sum and difference rule. Sorry, this was additivity. This is sum and difference. And you don't need to know the difference between them. Just know that you can split them up. So I split them up using that addition sign. The other thing I'm going to use is that constant multiple rule, which says I can bring the 2 out to the outside, and I can bring this 3 out to the outside. So before I start subbing in numbers, I really have 2 times the integral from negative 1 to 1 of f of x dx plus 3 times the integral from negative 1 to 1 of h of x dx. And then if I look above, it says that the integral from negative 1 to 1 of f of x is 5. So I've got 2 times 5 plus 3, and this is negative 1 to 1 of h of x, which is 7, which gives me 21 and 10, which is 31. Okay, now I think we're going to encounter some issues. So hopefully you started to question these as you got there. The first one says 0 to 1 of f of x dx. So looking up here, I do not have any bounds that say 0 to 1. The closest thing I would have is negative 1 to 1 of f of x dx. However, we don't know what this graph looks like, so we don't know if I could just cut it in half or not. Maybe it's not symmetrical. Because we don't have any information, if you can't use one of the rules from before, which there was nothing that said that you could cut the bounds in half and get half the area. So this one right here is not possible with the given information that we had. If we had more information, I'm sure we could go through it. This one right here, same idea. So again, there's no rule that says if you know negative 1 to 1 that you could just multiply the whole thing by 2 and get double the area to change the bounds. So again, not possible. And you should get not possible for this one too. We know this one, negative 1 to 4 of f of x, we actually already found it. So this one would be 3 if we split this up. The issue is you don't know negative 1 to 4 of h of x. We know negative 1 to 1 of h of x. So again, not possible. There's no rules to say that we can work with those. Okay, and that's example 1. Example 2. This one right here is using that max-min inequality rule. So if we want to scroll back really quick or flip backwards, the max-min inequality rule says if you take the minimum value of f times b minus a, has to be less than or equal to the integral from a to b of f of x dx, which has to be less than or equal to the maximum of f times b minus a. Okay, so we're showing that this right here is less than 3/2, so really you only need the upper half of the inequality. But just to show you one more time, it says the minimum value of f times b minus a has to be less than or equal to the actual integral, which has to be less than or equal to the maximum value of f times b minus a. So again, I'm trying to show that it's less than 3/2, so I can just work with this part of the inequality. You can do all of it if you want to, but okay, so I'm going to start working. So 0 to 1, again, if you want to pause and try this on your own, this would be a great time to do that. If not, you can just kind of watch what I did. So what I did there was I just copied this down. It has to be less than or equal to the maximum value of f. So let's talk about this graph right here. So let's pick it apart. Cosine of x, the maximum value of cosine of x is 1, right? So it goes up to 1 and down to -1. So 1 plus 1 is 2, so it's just this graph that's shifted up. And then the square root of 2. So the maximum value there is the square root of 2. And if you were to graph it, you would get that as well. B minus a is your bounds, so this would just be times 1 minus 0, or just 1, which means that this integral here has to be less than or equal to the square root of 2. The square root of 2 is approximately 1.414-ish. We are trying to show that it was strictly less than 3/2, which is equal to 1.5. So this integral right here cannot be more than 1.414 blah blah blah, or the square root of 2, which means it has to be less than 1.5. So we just showed that. Okay, this part here is actually very, very, very important. You're going to see this all the time, all the time. So if your function is integratable, or integrable, means the same thing, on the interval from a to b, it's average or mean value. Now I'm talking about mean value, I'm talking about a y value. So the average value that it takes on, the y value that splits in half the top and the bottom, is going to be given by this formula right here. So basically you find the integral and you do 1 over b minus a. So if you think about this, an integral is just the sum of all of these different areas, right? So we just did these Riemann sums, and we talked about how, well, hopefully we talked about, I don't know if we mentioned or not, but hopefully you understand that the more subintervals you have, the closer to the actual area or integral you are. So if you remember from probably 7th grade, or maybe even a little statistics along the way, when you're finding an average, you add up a bunch of things and then you divide by how many things are there. So that's really what this is doing. To find average value, you add up a bunch of areas and you divide by the interval that you're there, how many things are in the interval. Okay, so this one right here, to find the average value, we're not using Math 9, we're just going to use the calculators. I will show you how to do that next time in class. We're actually going to use it. Hold on one quick. Okay, so writing the formula here, the first thing I'm going to do is recall the average value, because it says find the average value. So that's 1 over b minus a times the integral from a to b of f of x dx. Okay, so my bounds here are from 0 to 3, so I'm going to do 1 over 3 minus 0 times the integral from 0 to 3 of f of x, I'm sorry, not f of x, we can actually plug in the function now. So the function is 4 minus x squared dx. Okay, so we're going to remember that. We're going to go over the calculator to evaluate this. So if you have your 89 with you, you'll want to get it open. Hold on one second. Okay, so when you're here at the calculator, what you want to do is you want to go to insert a calculator page. Okay, we're going to do this differently. We're going to go here, go plus page. Oh gosh, what are you doing? Let's go home. Let's open up a calculator page. Okay, so we go to menu. We're going to go to calculus, and then you should see this integral option. So I'm going to click integral. We are going from 0 to 3 of the function 4 minus x squared. So 4 minus x squared. Nope, not that squared. 4 minus x squared. And then dx. And that gives me the integral is equal to 3. So that means that this integral right here that I just typed in was equal to 3. So this is equal to 3, and then this is going to be 1 over 3, so a third times 3, which is equal to 1, which means that the average value is equal to 1. It does have to take on that value at some point, so if I set this equal, again, a value means a y value. 1 equals 4 minus x squared. Subtract 4, you get negative 3 equals negative x squared, or x squared equals 3, so x will equal plus or minus the square root of 3. Because we're in the interval from 0 to 3, I only want to consider the positive one. So if we were to go back to a graph screen, and we're going to type in that 4 minus x squared graph. Click enter, there's that graph. If we were to go to the square root of 3 and then 1, that's where the graph would be, the average value would be cut in half. Okay, average value of a function. So that leaves me with, that is it. Okay, thanks.